Hey, what's up guys? In this video we're going to solve this coding interview problem, longest palindromic substring. Given a string S, return the longest palindromic substring in S. What is a palindrome? A string is a palindrome when it reads the same backward as forward. For this string ABA, these strings read the same backward as forward, ABA and ABA. So this string is a palindrome string. For this string is not read the same backward as forward. Forward AB and backward BA, so they are not same. So this string is not a palindrome. Alright guys, this is the definition of palindrome. Now let's take some example. If you're given string equals to BA, BAD, you have to find the longest palindromic substring. So in this string, this is longest palindromic substring, or we can say ABA is the longest palindromic substring. These two strings contains the same amount of character. We can return any of them. So our answer could be BAB, or our answer could be ABA. Alright, for this given input we should return BAB or ABA. If you're given S equals to CBBD, in this case this is the longest palindromic substring BB. BB reads same forward as backward. Alright, so for this given input we have to return BB. If you're given S equals to A, we have only one character and this character reads the same forward as backward. So for this given input we have to return A. Now how we can find the longest palindromic substring? We can solve this problem using Maneser's algorithm that takes linear time complexity, but Maneser's algorithm extremely difficult and that's not expected in an interview settings. In this video we're going to solve this problem by expanding around center. Alright, let's see how we can solve it. Now I'm going to go through the intuition to this problem. For sake of understanding, let's assume we're given a string equals to BA, BAD. First, our goal is to find the length. The length is max of length 1 and length 2. Length 1 equals to length of substring when I is the center. Here substrings means palindromic substrings. Length 1 when I is the center. Length 2 when I plus 1 is the center. For each iteration we have two center, I and I plus 1. Alright, for first iteration I point to this character B, we have start and end, and this is our center. So the length of our longest palindromic substring at this center is 1 because we can't expand to this center. On the left we have no character. So length of longest palindromic substring at this center is 1. And here we have start and end. With start and end we can return the longest palindromic substring. Initially we have this start and end equals to 0. So initially our longest palindromic substring is this first character. And here we have this if condition. This if condition will find out the perfect start and end for a palindromic substring. Our next center is this, okay? When we have this center, our start is pointing to this character B and end is pointing to this character A. And we see that start and end are not equal because they're different character. So the length at this center of longest palindromic substring is 0. So max of 1 and 0 is 1. Alright, if we have the length is 1, the start and ends remain the same. You can calculate that using this code. For next iteration, I is pointing to this character A. We have start and end, and this is our center. At the center, we can expand around it. We have on the left B and on the right B. So we expanded it and we can't expand anymore. So here the length of longest palindromic substring is 3. Then our next center is this. Okay, when we have this center, we have start equals to A, end equals to B, and they are not equal. So the length of longest palindromic substring at this center I plus 1 is 0. So max of 3 and 0 is 3. In this case, start and end will be changed. Start will be 0 and end will be 2. You can calculate using this formula. Now for next iteration, I will point to this character B. And this is our center in this case, and we can expand around this center. If we expand it, start will be shifted to this character A and end will be shifted to this character A. Alright, and we see that they're equal. If we expand further, we see B and D that not a match, so we can't expand it. And the longest palindromic substring at this center I is 3. Then our next center is this. And at the center, the longest palindromic substring is 0 because B and A are not the same. And the maximum of 3 and 0 is 3. In this case, the start and end will be changed. Start is 1, 0, 1, the index, and end is 3. And you can calculate using this formula. Then for next iteration, I will point right here. And this is our center. In this case, the longest palindromic substring is 1. If we expand, we see start will point here and end will point here, and they are not equal, so we cannot expand anymore. The length is 1. Then the next center is this, and here we have the length of longest palindromic substring is 0. Alright, the max of length 1 and length 2, that means 1 and 0 is 1. Length is not greater than end minus start. So it will not change the start and end pointer. Then for next iteration, I will point right here at D, and the longest palindromic substring here is 1. And we can't expand start and end at this center because on the right we have no character. Then our center will be this, and right here we have no element on the right side, so the length of longest palindromic substring at this center is 0. So here 1 for at I, and for at I plus 1 is 0. So max of 0 and 1 is 1, and that is not satisfies this condition. So start and end will not be changed here, and our longest palindromic substring is this from 1 to 3. And that will return to our function. This is my solution to this problem. For the worst case scenario, it will take big of n squared time complexity, and it will take constant space complexity since we're not using any additional space. This is my solution to this problem. I'm not going to go through the code. I'm going to leave the code for you, and I'll attach the code in this video. Check that out. Thanks for watching this video. I'll see you in the next video.